This video covers section 3.2, graphing equations in two variables, objective 1. Graph a line by plotting points. The graph of an equation in two variables, x and y, is the set of points whose coordinates x, y in the xy plane satisfy the equation. When you have an equation like y equals 3x minus 2, there are infinitely many points that satisfy the equation. Since there are too many to list, we like to visualize them by graphing the equation. The graph serves as the solutions or solution set to the equation. And so to graph an equation, we find several ordered pairs that satisfy the equation. We then will plot those points in the rectangular coordinate system and connect the points with a smooth curve or line. In this case, it's always going to be a line. So we start by making a table of values for the equation. And I want to start off with the easiest one first, which is x equals 0. Since y is equal to 3 times x minus 2, if x is equal to 0, then y is equal to 3 times 0, which is 0 minus 2, or negative 2. So we get the point 0, negative 2. So we go to the point where x equals 0 and y equals negative 2. Now we plug in x equal to 1, and y is 3 times x, or 3 times 1 minus 2, or 3 minus 2 is 1. And that point is 1, 1. So we go over to x equal 1 and y equal to 1. Get 1, 1. Plugging in x equal to 2, we have y equals 3 times 2 minus 2, which is 6, minus 2, which is 4. And so we get the point 2, 4, and we go over to 2, and 1, 2, 3, 4. Doing one more of these points on the right side of the y-axis. If x is equal to 3, we have 3 times 3 is 9. Take away 2 is 7, giving us the ordered pair 3, 7. So we go over to 3 and go up to 7. For x equal to 4, I recognize that these y values are all increasing by the same number each step. 3 plus 1 is 4. 3 plus 4 is 7. 3 plus 7 would be 10. Doing that one more time. 3 plus 10 would be 13. So I put the point 410 on there. The point 513 would be slightly off the graph paper. And so now I want some points on the other side of the y-axis, namely negative 1. Plugging in negative 1 for x is negative 3 minus 2 is negative 5. That point is negative 1, negative 5. And plugging in negative 2 gives us 3 times negative 2 minus 2 is negative 6 minus 2, which is negative 8. Negative 2 and negative 8. On this side, we see those points are getting smaller by 3. So negative 8 minus 3 would be negative 11. And those points are all solutions to the equation. And then any point in between those, once we connect the points with a straight line, all of those points on that line are solutions to the equation. And so that's the way to solve this equation, y equals 3x minus 2. We've graphed all of the points that satisfy the equation. Since we saw that that equation had a graph that was a line, we go ahead and label these types of equations as linear equations. A linear equation in two variables is an equation that can be written in the form ax plus by equals c. A, b, and c can be any real number, and a and b, we don't want them both to be 0. Any equation written in this form where the x and the y are on the same side of the equation is said to be in standard form, as opposed to the one before it, y equals 3x minus 2. We saw this y equals 3x minus 2 as pretty easy to be plugging in x values and finding the y values. When it's in the standard form, 2x plus 3y equals 12, we have a little bit of a tougher time plugging in the x values and finding the y values, because every time we plug them in, it's an equation. But we have learned how to solve for y. We want to take this equation and first solve for y. Once we have y solved for, it's going to be easier to plug in the x values. So we achieve that by subtracting 2x from both sides. Gives me 3y equals negative 2x plus 12. Now when we divide by 3 on the left, that cancels the 3, but we have to divide each of these pieces by 3, giving us y equals negative 2/3 x plus 4. All right, so now we look at the equation y equals negative 2/3 x plus 4, and we plug in values to this equation. Like I did before, we want to always start off with x equals 0. Y is going to be negative 2/3 times 0 plus 4, and negative 2/3 times 0 is 0, plus 4 is 4. And if you plug in x equal to 1, you'll get negative 2/3 times 1 plus 4, which is negative 2/3 plus 4, which gives me a fraction. I don't want to get a fraction. If I can get around it, I will. And so we're going to, rather than plug in x equal to 1, since we recognize that this denominator is 3, only use multiples of 3 for your x values. If I plug in multiples of 3, like 3, 6, and 9, then when I plug them in, negative 2/3 times 3 over 1, the 3's will cancel each other out, leaving us with negative 2 plus 4, which is 2. If x equals 6, then 3 goes into 3 once and into 6 twice. And negative 2 times 2 is negative 4 plus 4, which is 0. If I plug in 9, three goes in 3 once, into 9 3 times. Negative 2 times 3 is negative 6 plus 4, which is negative 2. As we do these problems, we want to always recognize what's happening to the y values as I increase the x values by the same amount. 0, 3, 6, 9, increasing by 3. The y values have gone from a 4 down to a 2, down to a 0, down to a negative 2. These are decreasing by 2. The next one in line would be 12. Decreased by 2 on the y is negative 4. Now let's see what's happening on the other side. Negative 3. Y equals negative 2/3 times negative 3 plus 4. That's negative 3 over 1. The 3's cancel. And that's 2 plus 4, which is 6. If we plug in negative 6, that's negative 2/3 times negative 6 over 1 plus 4. 3 goes into 6 2 times. That's negative 2 times negative 2, which is 4, plus 4, which is 8. On the other side, we see 4 to 6 to 8. Adding another 2 would put us at 10, negative 9, comma 10. Adding another 2 would put us at 12, and that would be the negative 12. So we have negative 12, comma 12, negative 9, comma 10, negative 6, comma 8, negative 3, comma 6, 0, comma 4, 3, comma 2, 6, comma 0, and 9, comma negative 2, and 12, comma negative 4. They all lie on the same line. That leads me to believe I have not made any mistakes. And that would be the graph of the equation 2x plus 3y equals 12 by plotting points. This concludes the video for section 3.2, graphing equations in two variables. Objective 1, graph a line by plotting points.